I would like to give an introduction about him and his expertise. Dr. J. Somashekar, as a resource person and speaker, he has delivered 145 technical talks of AICTE FDPs, ISTE FDPs, STTPS, UGC FDPs webinars in 12 states of the country. He got all India rank of 43 in the GATE exam with 98.4%. He has 16 years of experience in teaching and 6 years of experience in research. He has published 23 research articles in leading journal indexed in SCI and Scopus, conference proceedings, and 2 international textbook chapters. Now, Dr. J. Somashekar sir, can deliver his keynote.
Yeah, thank you, madam. Madam, whether my screen is visible, madam?
Yes, sir.
Okay, thank you. So good afternoon, all the participants. So welcome to day 2 session of 5 days FDP on image processing using Matlab. So in first day, yesterday we covered basics of image processing, what is digital image and digital image processing concept, and what are the applications, what are the digital image processing techniques, and what are the tools for image processing. And we discussed introduction of Matlab. So why we have to go for Matlab, and what is the meaning of toolbox, and which toolbox we are going to use for image processing. All the basics we have covered in yesterday's session. So if anyone absent for yesterday's session, you can go through the recorded session if available. Now today we will see some of the image processing techniques along with hands-on Matlab. So whatever we have covered, some of the basic concepts yesterday session, that we'll try to do today in hands-on session, along with some of the image processing techniques we'll discuss for various applications. So this we covered yesterday. What are the tools for digital image processing? We have basically Scilab, Matlab, Image, like that. So many, even Python also we can use. But we are focusing our FDP Matlab, how we are using Matlab for image processing, or how to implement image processing techniques by using Matlab. So that is the scope of our session. Of course, if you know Matlab commands, it is almost similar to Scilab. Suppose if you want to implement these Matlab using Scilab, almost 90 to 95% same commands, same functions. Only thing is this is we have to pay money. This is costly and this is open source. But when you come to the application point of view, Matlab is very, very useful, and we have so many toolboxes and GUI facilities, all those things available. But Scilab for academic purpose, we can use easily because it's a free of cost, open source, and you can utilize for image processing if you are not getting Matlab software. But nowadays, most of the colleges having Matlab software. So that's why there is no need to worry about implementation of the functions or commands, or maybe various image processing techniques implementation by using Matlab. So obviously, Matlab is one of the fantastic tool for image processing, developing image processing programs. If not able to find software, then we can go for Scilab. Otherwise, we can utilize Matlab. So of course, for most of the researchers also using Matlab for the implementation of various image processing techniques. That already we discussed introduction of Matlab in yesterday's session. And this also I have explained yesterday's session. So Matlab work environment. So what is command window and what is current directory contents and file details, workspace and command history, all those things. So, but when you come to the latest Matlab version, like from Matlab 2013 onwards versions, so this command is included in the Matlab editor itself. There is no separate command window. So I will show when you are looking for hands-on. At that time I will explain that one. So this is actually a Matlab editor. So when you come to up to 2012, so there is a separate command window as well as editor window. But when you come to latest Matlab versions, so this editor is incorporated in the command window here only, and this command window somewhere you will get here. That I will show when you are looking for complete hands-on. At that time I will show that also. Now I'll come to the main thing. So what are the basic MATLAB functions and how we are looking for hands-on for this MATLAB functions. So after that, we'll go for some of the image processing techniques with the help of these functions, how to implement. So whenever if I go for first thing is how to read a image. So whenever if I take a C program, C++ program, we have to read the values. After that, we have to do some process. It may be addition, subtraction, then we have to print. But first we have to take values from the keyboard. That is the basic thing in C, C++. Same thing here also, how to read the images. So for that we have to use, because these functions or these libraries are available in the image processing toolbox. So imread and file name. So file name, maybe we can directly, if we have a file directory, some image file name, let us assume fdp1.jpg, directly we can use, or you can open image and you can see the properties there. We can find path of the image, so that file entire directory path we can copy paste, then we can read it. So these things, this is not that much encourageable. Directly we can use, because in current folder we have directly images, that image directly we can copy paste, always enclosed with single quotes. So this is the imread is a function. By using that we can read images from the folder, current folder, whatever current folder. If we have some other folder, we can go to that properties of the image and we can copy paste the path of the file, and based on that we can read the images. So once if we read the images, we have to display the image. For that we can go for a simple function that is called imshow. So whenever if I take, let us assume I have to read a image A, let us assume imread. After that we have to display that image. Anyhow, I will show these things in hands-on also. So imshow, and name of the image is A. And if you want to keep some title, we can keep title, let us assume input image, or maybe a sample image, like that we can keep. So here you can see, so imshow figure, leave it, later we will discuss. Imshow A, and title, whatever it may be, title we are planning to keep for that image, we can keep here title, and always it is enclosed with single quotes. So sample image, test image, like that. So these are the two functions. One is imread. By using that we can read images from the key folder, I mean current folder, and one is imshow. By using that we can display or we can show the images. So, and suppose whenever if you want to put some comments, suppose if we take C++, we can use comments like this, or maybe C language, we can use comments like this. So similarly, when you come to the MATLAB also, we can represent comment by using percentage symbol. Percentage, let us assume first MATLAB program, or maybe first image processing technique algorithm, like that we can put any comment by using the percentage symbol. So here you can, I will, up to here it's clear. Now I will show this one hands-on also, how to read and how to display. After that we'll go for further one. Just I will minimize this one. I will minimize this one. I already opened MATLAB. So here we have MATLAB. So suppose if you are looking for command window, so here we can see this is MATLAB version 2013A. You can see the leftmost corner version of the MATLAB. And in this MATLAB version from 2012 onwards, the command window is incorporated in the MATLAB editor itself. You can see here right side command window. If you want to close, just you can click that command window, fine. So, and you can write the program here, we can execute. Suppose if you want to use command window instead of editor, let us assume just we can drag like this. So let us assume and I will type some p equal to and imread. One more thing before going to that. So you can see here. So when you click here, we can find current folder. So where the images are stored, that folder we have to make it as a current folder. So based on that, we can see all the images. All the images are displayed here. So all the images, whatever images I'm using, all the images are displayed. Suppose if any image outside this current folder, then obviously you will get out error as image not found, like that. So make sure that in the current folder, all the images should be there, and that image we can use for our imread function, or that by using that we can read, and same thing we can display also. So this is very, very important. Otherwise we'll get error image not found, like that. Always make sure that in the current folder, so we have to select folder in which all the images should be stored. That images only we can use for reading or maybe manipulating something or processing something. So that is very important note. Now let me check command window. Later I'll come to the MATLAB editor for writing the program. So just we can drag this one. So let us assume here I want to drag this command window. So let us assume imread, and name of the image is, let us assume fdp1.jpg, enclosed with single quotes. So terminated by semicolon, enter. Now we have to display that one, im show, and the image stored in the variable p. So im show p terminated by semicolon. So we will see, yeah, we can find the output here. You can see the output here. So this is output. So whatever FDP1 something, some cameraman photo is there, that is a, so and you can see workspace also. So the image p, yes, all those things, whatever variables we have used in the command window, that variables are available in the workspace. Suppose if I want to put some title, let us assume im show, and I want to put some title, uh, sample test image. Still I'm not writing program, just I'm executing the commands in the command window. Later we will see program how to write, and based on that how to execute, and we will see the difference why we have to go for program MATLAB editor instead of typing the MATLAB functions in the command window. Just you can run, and you can see second image. So sorry, this is something else, and just here only. So indeed FDP1 next. So im show p, let me use some title, sample image. Now say terminated by, just you press enter, don't run, just you enter in the command window, no need to run, just you press enter, and you can see the output. You can see the output here, sample image. So you are able to see, I think, hope you can see the output. Sample image is the title, and whatever image we have stored in the variable p. Suppose if I want to go for some FDP2, let me use some other image. I want to read FDP2. So now let us assume sample image 2 and enter. So something other image is displayed, sample image 2, like that it displayed. Some image is displayed here. So now let me use again. Now just we can use CLC to clear the command. CLC is a command. By using that, we can clear the command. Whatever we have typed, it will clear. Just CLC, just we can terminate it by semicolon. Everything will be cleared. So always clear the command window by using CLC command. So this is very important, because enter MATLAB, we are going to use CLC command to clear the command window, so that whatever we have typed, everything will clear. And so now this is fine. Whatever we have executed MATLAB functions here, we got output. But the problem is these things not stored permanently, because when you want to make some product, obviously we have to store the programs permanently. Based on that only we can create a product. So for that, what we have to do, we minimize the command window. We can go for editor. You can see here leftmost corner plus symbol. We can click, and you will get a new editor. This is MATLAB editor, and we can type some program. Now whatever we have executed commands, and I will use here. First, always try to use, let us assume comment is first MATLAB program. Comment is always we have to use percentage symbol. So first MATLAB program, and CLC, so that we have to clear the window. And first let me use p equal to, sorry, p equal to inbreed. Let us assume some images. What are the images available here? FDP19, FDP19.jpg. So terminated by semicolon, and im show, the image stored in the variable p. So variable comma title first program output image, that is the title I'm keeping. Now once if we, just I'm reading, I'm displaying here, and CLC means we have to clear the command. If anything is there, previous outputs, all those things will clear. Now we have to run this program. So here you can see run button in the top of the editor. So just you can click that run. So when you click, automatically it will ask. So we have to give name for the program. Let us assume test 1. Already test 1 is there. Let us assume test 3. So test 3. So always the MATLAB program extension is .m. In C programming we have .c. In Java programming .java. In Scilab programming we have .scl or SCA, like that we have extension. Similarly here the default extension of the MATLAB program is .m. So just you can give the file name, automatically it will store with test3.m. Just you can save. Now you can see the output. So first program output image. Just we are reading the image by using the function imread, after that imshow title. Now again, okay, then again you will try to execute, run. So here instead of 19, let me use 11. So I think, yeah. So this is the first program. One more image I have read. So that is called program, FDP11, that is the name of the image. And just I have read and displayed that. So the extension is JPZ. So in which just we have done how to read the image, how to display, and how to clear the command window. So by using CLC function. Now, sometimes we have to convert the given image into a grayscale image. We already discussed what is color image, what is grayscale image. So in color image, we have 3 channels RGB, and sometimes it is difficult to process all the 3 channels. For that, we have to convert it into single channel, that is called grayscale image. How to convert grayscale image? So here we have to go for a function that is called, so let us assume B equal to RGB to gray. This is a function. By using that, we can convert the color image into grayscale image, and the color image stored in the variable P. So that's why RGB to gray P, and terminated by semicolon, and imshow first program. Let us assume the title is color image. Color image, and imshow, and the grayscale image stored in the variable B. So comma, some title I want to keep. Let us assume your title is grayscale image, 8-bit image, terminated by semicolon. Now let me run this program. When you run, you can see grayscale image. So only figure 1 grayscale image, but color image is missing here. As you can see here, so color image we are not able to see. So why means the previous image is overlapped with, overlapped with the second image, that is called grayscale image. So in such scenarios, we can use the keyword that is called figure, imshow P and figure. So now we will see, yeah, we are able to see 2 outputs. So figure 1, figure 2. Along with one more previous figure also, we are able to see 3 figures. So actually it should be 2. So such type of scenarios, what we have to do, we have to go for close all. Close all. Now let me execute this program. So we are able to see only 2 images. One is color image, one grayscale image. So what are the observations here? So whenever if you want to close all the previous figures, just we have to use local. So just I am giving comment here to close all the figures, previous figures. Otherwise, previous figures also available, and current program execution figures also will display. Then you will get confusion. So CLC is nothing but to clear, sorry, percentage. Just percentage is for comment. So to clear the command history, command window history, command window history. So CLC. So if you are not using CLC also fine, no issue, but try to use always close all. Otherwise, it will overlap with the previous images, and you will get 10 images at a time instead of 2 images output. Then you will get confusion which images are the actual output of the current program. So because of that reason, always try to make use of this close all command. By using that, we can close all the previous figures. Now let me execute run. So now we can see we are not able to see any previous images, just these 2 images. So one is color image, one is grayscale image. And now I'll go for one more image. Let us assume FDP12, some image. So this is a grayscale and color image. Both images are available. So up to here, there is no issue. So here up to that, I think this. So here I think it's clear. So we have to read the image, and we have to display the image by using imshow function, and how to convert a color image to grayscale image by using RGB to gray function. And what is the significance of CLC? We have to clear all the command window history, what are available previously. And close all means we have to close all the figures, that means previous program figures. So when you are executing the current program, all the previous figures should be close. For that, we have to use close all command. So these are the main thing: CLC, close all, imread, and imshow, and RGB to gray. And one more thing is how to put title for any images. We can use title and the title should be enclosed with single quotes. And whenever if you go for figure, if you are not using figure only, it will display one figure. Suppose if you take this case also, so let me execute this program without figure. What happens, we will see. We already done one example. Again, let me execute one more program. So you can see here only grayscale image, the last image only it will display. So previous image not displayed. So because of that reason, what we have to do, always try to use figure. So figure show p, and yeah, no issues. So figure, now we are able to see both images. So grayscale image as well as color image, you can see the output. So this is advantage when you are using figure before show function. I hope it's clear. These are all simple basics, and make sure that always the current folder should be image folder. Otherwise, you will get error. Let us assume, I will use some image which is not available in the current folder. Let us assume FDP 102. So I'm not getting any output. I'm getting some sound. What it indicates, so this image is not found. How to find this error? So you can click this command window. When you click this command window, you can see test3, that is the program name, and FDP 102 does not exist. That means the image is not found in the current folder. So because of that reason, always make sure that the current folder should be image folder. Otherwise, you'll get this type of errors. So image not found. Just a second. So current folder, always make sure that images should be stored in that current folder. Then only we'll get proper output. Otherwise, we'll get this type of error. So let us assume I will execute same program by making CLC as a command. I mean comment. So just I will execute 102 or maybe 105, some other name. So again, I'm getting error, but you can see the command window. When you see the command window, so previous error also available, and current program error also available. Why we are not using CLC? If you use CLC, this previous error will remove immediately. That means it will clear the command window history. So that's why now let me use, I will remove comment CLC. Just I will use CLC without any comment. If I execute this program, now you will see command window. So previous whatever errors, whatever data, everything is cleared. Just a current program error. So that is called FDP 105.jpg does not exist. So that's why always make use of CLC, so that we won't get any ambiguity. Otherwise, suppose all the previous program errors, current program error is available, you will get confusion. Which is the actual current program error? Maybe this is also possible. Maybe other things, whatever errors displayed previously, that also possibility is there. Because of that reason, you will get sometimes ambiguity. So that's why always try to use CLC as well as close all, so that we can close all the previous programs figures, as well as we can clear the command window history, so that we can find exactly the current program execution. Suppose if I use some FDP 11, I think this image is available in the folder. When you run this one, I think this is available. You can see here. So color image and grayscale image. When you click command window, so here no error. So whatever errors displayed for previous program, that is cleared. Why we used the command CLC. So here also, if you are not terminated by semicolon also, there is no issue. So we will get error. Not like C program, it's mandatory. Suppose if I remove here, so you will get output, there is no issue. But maybe you will see, is there any error? Yeah. When you remove this semicolon, you will get output as all the image values. You can see here all the image values. So let us assume here terminated by semicolon, and here imread and fdp11.jpg. When I'm trying to execute this run, and in command window, we are able to see all the image values, whatever values for the grayscale image, all the image values are available here. Because image is nothing but matrix, and depends on the color, it will take automatically 0 to 255. So all the values, all the image values are available, as you can see here. So now I want to clear this command history. Just you can type CLC, so it will clear. Now suppose if you want to read matrix and display. So A equal to some matrix I want to read. Let us assume capital A equal to, and always it should be square bracket. Let us assume 2 comma 3 comma 4. This is first row terminated by semicolon. Next second row 4 comma 5 comma 6 terminated by semicolon, 6 comma 7 comma 8. So close the square brackets, enter. So you can find the matrix elements. So 2, 3, 4 first row. So first row terminated by semicolon means all the elements before semicolon, that is first row. And 4, 5, 6, 6, 7, 8. Suppose I want to read some values. Let us assume A of 1, 1, 1. So you can see first row, first column. So first row, first column is nothing but 2. In this matrix, first row, first column. Here rows and columns will consider from 1 to m, 1 to n only. So A11, that means what is the meaning? First row, first column. First row, first column is 2. Suppose I want to display last value, that is 8. That is the third row, third column. So instead of 1, 1, make it as 3 comma 3. So 8. So now I'll clear the command window by using CLC. Now what is the matrix here? So matrix, let me let us assume 2:4. Now instead of using elements 2, 3, 4, we can go for 2:4 like this. So 2:4 and 4:6 and 6:8. So what does it mean? Whenever if we use like this, so 2:4 means 2, 3, 4 it will consider. 4:6 means 4, 5, 6. 6:8 means it will take 6, 7, 8. Now when I enter here, so all the matrix elements are displayed here. Suppose if I go for a 2:1 2:6. So suppose if I want to make it as an increment each time a 2, 2, then what we have to do? So we have to make a matrix. Let us assume. So I will use clear screen, then you can understand clearly. CLC. So capital A equal to 1:2. So I want to display first row as 1, 3, 5. So each time 2 increment. That's why 1:2. 2:5. What does it mean? So 1 is the starting value, last value is 5, and 2 values are increasing. 1 plus 2, that means 3 plus 2, 5. Terminated by semicolon, that is the first row. Second row starts from 5 and increment is 4. So 5, 4. Let us assume 5 plus 4, 9, 9 plus 4, 13. So that is the second row. And last row, let us assume 4:2, 2:2, otherwise 3:10. So enter. You can see here, instead of typing all the values, so first row is 1, 3, 5, second row is 5, 9, 13 each time. So what does it mean here? 1:2, 2:5. 1 is the starting value, and each time increment is 2. In for loop also, for I equal to 1, I less than or equal to 5, I plus plus. That is each time I value increased by 1. Here instead of I plus plus, I equal to I plus 2. That is the meaning here. So A equal to, this is a 3x3 matrix. So these are the simple observations how to create a matrix and how to display. We can directly create and we can display, provided that each row terminated by semicolon, or if you want to write just increment for array elements for first row, we can go for 1:2, 2:5. Accordingly, we can write second row, third row. Finally, we can find. Suppose if you want to access any element, we can go for name of the array A and within open bracket. So let us assume I want to go for first row, second column. Just we can enter, the element is 3. So this is the way we can access any element, one element of the matrix. Of course, we can use for loop also, that we will see later. While writing program, we required for loop. All those things we will discuss in detail later. So this is clear here. So what are the things we discussed? So CLC, close all, inbreed, grayscale conversion, and imshow, and why we have to use figure, and how to create a matrix and how to display, and various versions, and how to access any particular element of the matrix. So these are the things we discussed. Now the question is, when you execute this program here, as you can see here, so figure 1, figure 2, these two images are displayed, two separate figures. Instead of that, why can't we make one figure, two images? So that means I want to display these two figures in one image only, instead of figure 1, figure 2. So for that, we have to go for one function that is called subplot function. So why we have to go? Suppose if we have 10 images. I can't display 10 images. Instead of that, I want to make one figure in which all the 10 images I want to display. So such type of case, we have to go for subplot. So here, what I'm trying to do, so just I will remove this figure, whatever I have written. So what is the objective now? How to use subplot? It means how to display more than one image in one figure. So maybe column wise or row wise. So for that, we have to use subplot. This is a function, and here we have three parameters. Subplot is a function. You can see here subplot m comma n comma p. M indicates number of rows, n indicates number of columns, p indicates position of the figure. So let us assume here I want to display only two figures. That's why I want to make one row, two columns. One row, one comma. Three parameters we have totally. This function will receive three parameters, m and p. M indicates rows, n indicates columns, p indicates position of the image. So here I am taking one row, two columns, and the first image is color image. So first position is 1. So im show, what is the name of the image that is stored in the variable p, and title color image. Next, subplot. First two parameters are fixed. So what are the first two parameters? 1 comma 2. What is last parameter? 2. The grayscale image should be displayed in the second position of the figure. So that's why I make it as 2 comma im show. So what is the variable of grayscale image? B, and the title should be grayscale image. Always it should be enclosed with single quote. So grayscale image terminated by semicolon. So here so now run the program. You can see here. So in one figure, we are able figure 1 in which we can see. So 2 columns, 1 row, and color image, grayscale image both. Because if you are looking for any research article at that time, we have to make like this, and same screenshot you can paste in our publication. I mean paper research article. So here I have to make one row and two columns. For that we have to use a function that is called subplot, and this function will take three parameters, m and p. M indicates rows, n indicates columns, and p indicates position of the image. So this is first position, color image is first position, grayscale image is second position. Suppose I want to make, instead of one row, two columns, 2 rows, 1 column I want to make. In that case, what we have to do? 2 comma 1 comma 1. 2 comma 1 comma 1 means 2 rows, 1 column, and 1 indicates position of the figure, that is p. Similarly, second one, 2 comma 1 comma 2. So first two parameters are fixed for second subplot. So now let me execute this program. Let me run this program. You can see here we have 2 rows and 1 column. You can see the subplot function also. Subplot 2 1 1. That means 2 rows, 1 column, and last parameter is position of the figure. So first figure is color image, that's why 1, and second figure is grayscale image, that is 2. That's why second image is grayscale image, and first image is nothing but color image. Sometimes instead of using separated by comma, you can use directly 2 1 1 also. So there is no issue. 2 1 1 also you can use, or 2 1 2 also you can use. You can separate rows, columns, position of the figure by using comma, or you can use directly 2 1 1 2 1 2. So if you run this program, you will get output. There is no issue. So you can use like this. I'm writing comment here. You can see here. So you can use 1 comma 2 comma 1, or we can use 1 to 1. So both are same. You can write while using the subplot, you can separate the parameters by comma, or without separating also directly we can write. So 1 to 1 like that. So based on that, it will consider first parameter is nothing but row size, and second parameter indicates column size, and last parameter indicates position of this. Suppose I will go for let us assume 4 images. So let me take 2 more images in read, and b equal to 1 more image in read fdp 12.jpg. that is 1 more image I'm taking, and x equal to, so instead of b, let us assume k, because already that variable is available. So x equal to RGB to gray, and the image stored in the variable k. So now we have to read 2 images. We have to display 4 images totally, because to reading whatever images we have read, that 2 images along with grayscale images. So that means we have total 4 images. We can make a 2 by 2 matrix, 2 rows, 2 columns. So for that subplot, 2 rows, 2 comma 2 comma first image location is, so im show color image 1. Just I want to make color image 1. Next grayscale image 1. So here also 2 rows 2 columns. The first two parameters are fixed, 2 comma 2, and the position is second position, so we can put 2. And we have two more images, so subplot, so 2 rows, the first two parameters are fixed, 2 comma 2. The position is 3 here, so first row is over, first second. Now third position we have to display the other image, so im show the image stored in the variable k, title I'm giving color image 2, terminated by semicolon. If you are not using semicolon termination also, there is no issue, you will get output. But in command window, the entire image will display in the matrix form. So that's why we have to use semicolon. If you are not using also fine, there is no much issue. But sometimes if you are getting error, it is difficult to search for that error in the command window because so many matrices will display it. So 2 comma 2 comma 4 im show, and last image is X, title grayscale image, and let me use 2. Now I will execute this program. As you can see here, so it is a 2 by 2 matrix, and color image 1, that is the first position, grayscale image 1, that is the second position, color image 2, that is the third position, grayscale image 2, that is the fourth position. So that's why, so in subplot also we are using first two parameters are fixed, and last parameter is position of the image. So 1 2 3 4, any one value possibility is there, but rows and columns are fixed here, 2 rows 2 columns, and rest of the third parameter value varies, it depends on the position of the image. So hope you understood the various versions of the subplot, how we have to execute this one. Suppose if you are not using a comma also fine, there is no error. Suppose subplot, I will remove these commas. I'm not separated by using comma, just I'll remove. So because we are using anyhow a single numeric value, that's why there is no ambiguity. Suppose if we have 20 rows, 20 columns, at that time there is a confusion. At that time we can go ahead with comma by separating this. So now I'll execute this one. Just I have removed the comma. Now you will get same output only. There is no issue with output. So we are getting output. So 2 color images and 2 grayscale images, provided that our objective is to display in one figure with 2 by 2 matrix form, that means grid form, and we are able to see all the 4 images in one figure instead of looking 4 separate images, what we have done for other programs. Now I will minimize. So hope up to here the basic things over, how to read the image, how to display the image, and how to convert the RGB to gray. Why we have to convert? Because yesterday class I given clearly what is grayscale, what is RGB, what is binary image, why we require. So the main objective why we have to convert RGB to grayscale means instead of processing 3 channels RGB, we have to process for single channel. So that's why we have to convert. And one more function we discussed, what is subplot and how to mention title for the images, and what is CLC, what is close all. So in this small program we can find so many Matlab functions. All these Matlab functions are available in the image processing toolbox, because toolbox is nothing but set of all M files. By using that functions we can read directly, otherwise we have to write a big code. So that's why no need to write a complete code, just we can use that function, and based on that we can execute the program. Even subplot, you can see this is a function. If you go for image processing toolbox, we can find subplot function, but here it will receive 3 parameters, x, m, n, p, m, p, rows, n, columns, p, position of the image. Hope up to here clear, the basic functions clear, and by using that what are the image processing techniques, how we are going to execute, that we will see now. Now I will minimize this one. If you have any queries, ask me, otherwise I'll go through the presentation. Yeah. So these things we discussed. So imread we discussed, and imshow we discussed, and what is the requirement title, and what is percentage symbol for comment. And also we discussed subplot. So here you can see a subplot MNP divides the current figure into M by N grid and creates axis in the position specified by P. P is the position. So this we already discussed with so many examples. And these examples also, how to create a matrix, how to display also we discussed. So that is already done. and the subplots only. These are all screenshots what I have executed previously. Just here also we discussed. So subplot 2 rows, 1 column, like that we already done hands-on also. And here 1 row, 2 columns, that also we have done. And this is the color image. We can see RGB, and this is the grayscale image. And for that, sometimes we have to convert the color image into grayscale. For that, we have to use RGB to gray, that we discussed just now, and we executed also. And this also we have done, how to convert color image to grayscale image. And next one is how to convert image to binary, because this is also one type of image. So binary means it's a zeros and ones. So for that, what we have to do, we can go for simple function that is called im2 bw. So by using im2 bw, we can convert the grayscale image into binary image. So binary image means it's a form of zeros and ones. Zero means black, one means white color. Suppose if you see this image, first this is the color image, I have converted into grayscale. After that, when I converted it to binary image, so we can see only black and white colors only. Black means 0, white means 1. Because when you go for segmentation, we require this binary conversions. That at that time we'll discuss what are the applications we have. But here, just time being, so how to convert the image into binary image? Just we have to use the Matlab function im2 bw, and we can see various im2 bw. So now I'll move to one small example of this binary conversion. Same examples what we have executed, that only I'll try. So let me use some new editor. So let us assume CLC, just one command I'll execute for image to binary, how to convert J equal to directly RGB to gray inbreed fdp11.jpz. Let us assume K equal to im2 bw. You can see here. So when you want any help, so I have typed the command im2 bw, and just you can press F1. When you press F1, you can see the description of this im2 bw, convert image to binary image based on the threshold. So time being, you can hold what is threshold. I'll explain when you are looking for, when you are discussing about segmentation. At that time, thresholding is very one of the segmentation technique. At that time, I'll explain what is the meaning of threshold, how to fix all those things. But timing is no need to worry about this one. So whenever if the main objective here, what I'm trying to discuss. So whenever if you are looking for any help, just you can press F1. So just you can press F1. You can see the description of the function, Matlab function. So im2 bw. Suppose if you forget anything, also you have examples also there. So suppose if you press here, you can find so many examples also. So that examples also you can consider for your execution of the program. So let us assume J and figure in show K. So I have to make some program name test file. Let us assume. You can give any name, no issue. I think some error I'm getting. What is that error? Command unbalanced or unexpected parenthesis bracket, something is missing. So here we have two open brackets but closed with one bracket. That's why we are getting error. So now you can see, so binary image. So FDP11 is color image. I converted it to grayscale. Binary. Finally, we are able to see binary. Later, we will see what is the significance of this binary image, especially in segmentation concept. We have huge number of applications. So at that time, we'll discuss in detail about this one. So here my objective is how to convert the given grayscale image into binary image. That is the main objective. So just I'll minimize this one. So up to here, we completed all the basic functions, whatever required for our programs. And this I will explain this one later. And I already told you what is CLC. It will clear basically command window. And clear all means it will delete all the variables in the workspace, but time being for us not required this one. And close all is very important. So close all means it will close all the previous program executed figures. So obviously Matlab is case sensitive. So that is also very important. Now we'll go to the image processing techniques one by one. So up to here we completed. So basics of image processing and basics of MATLAB functions. Now we will see how we are going to apply MATLAB for the various image processing techniques. So for a research point of view, or maybe for project point of view, from this onwards, very, very important. But without knowing previous things, we can't do these things. That's why we have complete all the basics. That means all the basics means whatever required for our concepts that we have completed. After that, we'll see one by one how we are going to write MATLAB program by using the previous functions what we have done, along with image processing techniques. There also we have direct MATLAB functions that we will execute directly. No need to worry. Maybe for some for some of the techniques we can write little bit code. It's not that much complicated also, because most of the image processing techniques we have direct inbuilt functions that we can use. Maybe sometimes we have to write simple programs also. Anyhow, that we will see in detail when you are looking for further concepts. Now, first one is image enhancement technique. So yesterday class session, I explained various image processing techniques briefly with input output. I did not explain complete intuition, all those things. Just I have given input output. Now we will see what is complete intuition and how to apply and how to execute by using MATLAB programs. So first concept is image enhancement. Image enhancement is very, very important as a pre-processing techniques. So without pre-processing, directly if you go for post-processing, then there is a possibility to get wrong results. So instead of positive cancer, you may get negative cancer. Instead of negative cancer, you may get positive cancer. Such type of possibilities are there. That's why image enhancement is very, very important when you are looking for image processing techniques, or when you are looking for deep learning, or when you are looking for machine learning, etc. So most of the time we have to apply pre-processing technique, that is called image enhancement. Then we have to go for post-processing analysis, etc. So basically in image enhancement, we have first thing is image smoothing, that we can call it as a noise reduction. So whenever if we have a noise, image having a noise, so we have to reduce it. Then only we are able to go for easily image analysis, or maybe further computer vision, etc. So suppose if we take rainy season, we can find lot of noise in the video also. So if you are watching, especially olden days, so we have Doordarshan channel. So whenever there is a rainy season, we are not able to see the video properly, because lot of noise, maybe dots you can find, because there is a heavy rainy season. Because of that reason, noise possibility is there. Even whenever there is no signal for audio also, so then you will get noise also. So such type of noise is also possible for images. So in that case, how to reduce the noise or how to minimize the noise? So that is called image smoothing, that we will see today, one image noise reduction technique. Based on that, we can go ahead with other noise reduction techniques also. So that is one of the image enhancement method. And image contrast enhancement. So whenever if we have a low contrast, how to increase the contrast? Suppose I have taken a photo in the dark room, then I'm not able to find how many number of students in the classroom, because there is a dark. Obviously, when you are looking for automation, difficult to identify, or difficult to enumerate, or difficult to count how many number of students in the classroom. So such type of scenarios, we have to increase the contrast. Then only we are able to find how many number of objects in the classroom. Based on that, we can go for further application. So how we are going to do contrast enhancement? So that technique also we are going to use, discuss, as well as hands-on. Whatever techniques I'm going to discuss, same thing we are going to implement by using MATLAB. And blur reduction, that also we'll see how to reduce the blurring. So these are the main image enhancement techniques. We will see one by one. So what is the image smoothing concept, and with examples and with hands-on by using MATLAB. So whatever commands we are going to use, almost same for if you are executing in Scilab also. So this is a brief introduction about image enhancement. Now we will see one by one. So first we will see image smoothing. So actually, whenever if I go for digital image processing, so there is a possibility of noise incorporated in the image. It may be additive noise or multiplicative noise, but finally some noise is incorporated. Because of that reason, it's very difficult to go for further analysis. Maybe, for example, if we take COVID-19 chest X-ray images, so if we have a lot of noise, then what happens? We will think the noise is nothing but infected region. Then obviously there is an issue for diagnosis or maybe detection. So such type of scenarios, you may get false classification, or maybe false prediction, or it may be false segmentation. So because of that reason, we have to reduce the noise. That is called one of the image smoothing technique is noise reduction. So we have to reduce the noise. Based on that, we are able to see the image properly. Even if we take cinema movie heroes also, so before off screen their faces little bit noise, maybe pimples or something is there, but when you come to the on screen, their noise, their faces are very good by means some filtering they are using, that means some noise reduction they are using. Let us some cream, we can call it as a makeup, etc. In similar fashion, when you come to the image processing also, we have to do some filtering, that we have to reduce the noise. By using that, we are able to see better quality of the image for further processing. So that's why image smoothing is very, very important. Let us assume here you can see some of the images having noise. So here first image having lot of noise, all the images having lot of noise. Here we have both grayscale as well as color images. In all the images we have huge noise, and because of that reason we are not able to see the content properly, which leads to the false prediction or maybe false classification. If you are looking for deep learning or maybe machine learning also, maybe if you go for image processing segmentation or image analysis also, you may get false prediction or we may get false results. Because of that reason, we have to reduce the noise. In all the 4 images we have huge noise. How to reduce the noise? For that we have various kind of filters. By using that, we can reduce this noise. So here we can go for linear filters. We can call it as a low pass filters, or we can call it as average filter. So this is one filter, and one is non-linear filter, or we can call it as a order statistics filter. By using these two filters, we can go for image smoothing, that is called noise reduction. So these we will discuss. All the non-linear filters or linear filters difficult to complete, but I will give some of the filters basic idea and with hands-on. Based on that, if you find any other linear filters in the textbook, I will show resources also. So we can execute by using similar kind of MATLAB code only. With small changes according to the filter, we have to change the MATLAB function. So we will see how we are going to apply non-linear filters to the given image. By using that, we can we will minimize the noise. We can't say reduce the noise, we can minimize the noise. Similarly, how we are going to apply linear filters or average filter, that is called mean filter, to reduce the noise. So here we have concept of spatial filtering, that time we can hold this one. I will explain what is the spatial filtering process, convolution process, all those things. But here we have one terminology that is called term that is called filter mask kernel window template. What does it mean? I'll explain. So basically the kernel mask is nothing but a small image that we have to apply to the given input image for noise reduction. So let us assume here, I will show clearly. So let us assume this is a window or maybe mask. Let us assume this is the 3x3 sub image I have. Anyhow, through examples you can understand. And this is the original image. This is the original image. So the image is nothing but matrix, rows and columns. And this 3x3 image is a filter. This we have to apply initially here. Then we have to move left to right. Then we have to move left to right. After completing, then again we can from top to bottom, we have to move down here. So here we have to apply, here, we have to like this. So anyhow, through example, you can understand how we are going to apply filter. Or maybe if you are looking for 3x3 filter, what is the meaning? We have to consider only 3x3 matrix as a kernel or mask. Or if we consider 5x5 filter, this is also matrix or image, sub image this is, and this we can apply for 5 rows, 5 columns to the input image. Like that, we have various sizes. We will see what is the impact of the size of the filter. So maybe we can apply 3x3. You may apply 5x5, you may apply 7x7. Again, you will get doubt. I'm using only 3x3, 5x5. What happened 4x4? What happens 6x3? That also I will explain why we have to choose only this odd number. Why can't you go for even number? That also I will explain when you come to the concept. There through example only I will explain. So basically, filter window or kernel is nothing but subimage. So the subimage size is minimum 3x3. Or if you are looking for better sizes, maybe 5x5, 7x7 we can use, and that filter we have to apply to the input image, but still we don't know how we are going to apply. Through example we will see. So here in spatial domain process, this we can call it as a noise reduction, in which we are using spatial domain. Of course, frequency domain also there, so that is not scope of our section. So especially for frequency domain, we require Fourier transform and what we can call it as a cosine transform, all those things. But we are looking for spatial domain processing, filtering process. That means directly we are operating on the direct pixels. So that means this is the input image. F of xy is nothing but the input image, and we have to apply some technique that is called transformation, and you will get output image that is called g of xy. So this is the image. F of xy is nothing but image having noise, and after applying transformation we can call it as image processing techniques. So noise is reduced here. So mathematically how to write? So g of xy is the output image with less noise. That how we got by applying the technique T to the input image f of xy. So mathematically we can write g of xy equal to T into f of xy, where T is a smoothing technique, or maybe non-linear smoothing technique, or linear smoothing technique. So this is a spatial filtering process where x and y are nothing but spatial coordinates. So I'm not talking about anything about frequency domain filtering, all those things. Just I'm looking for, so just I have to operate directly on the pixels x, y, and based on that I'm looking for a noise reduction or image smoothing. So this is a mathematical notation, simple one. Now we will see how we are going to smooth the given input image by using nonlinear filters. So we have nonlinear filters or order statistics filter. We can call it as a nonlinear filters or order statistics filters. We have median filter, that is one of the very important filter, and max filter, mean filter. These are the three smoothing nonlinear filters. So we will focus mainly on median filter. Of course, other filters also I'll explain. Even I will show hands-on and input output, what type of input output you will get after applying to the noisy image, that also we'll discuss. But median filter is very important, even if you research point of view also, because pre-processing is very important. There we can apply median filter to reduce the especially salt and pepper noise. So these are the three nonlinear filters. We'll discuss one by one: median filter, max filter, and mean filter. So let us assume whenever if you want to apply median filter, so the image having salt and pepper noise. What does it mean, salt and pepper noise? Suppose here let us assume, so 50, 5, 6, 7, 8. So this type of image having what we can call it as a salt noise. So highest value surrounded by lowest values. This is called salt noise. So you can see here 250 is a intensity value or a color value, and which is surrounded by the low frequency value. This is called salt noise. That is called 1. We can call it as a white color. Salt and pepper means black and white, so white color. Suppose what is the pepper noise? Pepper means black. So whenever lower value surrounded by higher values, here 10 is the central pixel value which is surrounded by the higher pixel values like 250, 240, etc. This we can call it as a pepper noise. So once again, this we can call it as a impulse noise also, impulse noise. So IMPULS, we can call it as a salt and pepper noise, or we can call it as a impulse noise. So whenever if we have image having this salt and pepper noise, we how to reduce? For that we can go for median filters, non-linear filters, in which median filter will help to reduce salt and pepper noise. So you can see one example. So this type of images, so if we take these three images, so these three images are suffering with salt and pepper noise. So black and white dots are available. Even when you see the rainy season also, you can find salt and pepper noise only in your video, I mean Doordarshan channel, or maybe video also, because lot of dots you can find, white, black dot, like that type of noise. How to reduce? We can go for median filter. Of course other filters also we can use, but median filter is one of the powerful filter. By using that we can reduce this salt and pepper noise. So how we are going to apply, we will see. So I hope you understood what is salt, what is pepper noise, and salt and pepper noise also called it as a impulse noise. So if you take this image, so you can see here, this is the actual image, and after converted into matrix notation, you can see 255, that is the salt noise. All the surrounding values are very low values. 255 surrounded by 20, 30, like that. That's why we can call it as a salt noise. That's why color is white here. You can see small white dot. And if we take here 0, so 0 means black color, black and white means 0 and 1. Here 0 means black color, and all the surrounding values are very high. So 250, 25, 30, like that. That's why 0 is nothing but pepper noise here. And same way here also you can see 255. So here also, I'm taking only portion of the salt and pepper noise image. So if you take entire image, you can find lot of zeros and 255, which is surrounded by lower values. Zeros means which is surrounded by higher values. Here you can see 255, which is surrounded by lower values. That's why which is we can call it as a salt noise. So this is the one simple image I have taken, and I after converted into matrix, so we can find easily the salt and pepper noise instead of what I have given example in the previous slide. So now how we are going to apply median filter, that's the process here. So how we are going to apply median filter to minimize the salt and pepper noise or to reduce the salt and pepper noise. So what we are going to do is, so let us assume this is the input image. So I am assuming, let us assume, so maybe this is a 7x7 image or maybe 10x10 image. So let us assume, so this is a 10x10 image, I am assuming. So now I want to apply median filter. What basically we have to do, we have to fix the filter kernel size. So I am assuming the size of the kernel or mask is 3x. This is the first step. So we have a 10x10 image and the size of the kernel mask is 3x3. Now what we have to do, this 3x3, first 3x3 we have to consider. Here we have 3x3. So 3 rows, 2 columns we have to consider. And in this sub image, this is called mask. So in this sub image, we have to find the median value. We know how to find the median value. Arrange the elements. Suppose if we take 5, 7, 9, median is nothing but 7. Suppose if we take 1, 2, 3, 4. So 2 plus 3 by 2, 2.5 is the median. So middle observation is the median. When you have odd number of observations, middle is the median. When you have even number of observations, average of middle values is nothing but median. So now I hope you understood why I'm choosing 3x3. When you choose 3x3, you will get total 9 intensity values, 9 elements. So how easy to find the median value. 9 elements mean median value is nothing but fifth element. So 4 this side, 4 this side, 4 plus 4, 8, and only one element left, that is middle element, that is the fifth element. We can find easily median. That's why always we used to consider the size of the kernel is nothing but odd size. Yeah. So first we have to find median for this. I will show anyhow numeric examples also. After that, we have to move next 3x3 and replace central pixel value by median. So again, we have to find 3x3 matrix, central pixel value replaced by median. Next, top to bottom, next 3x3, next 3x3. Like that, we have to apply this 3x3 mask to entire image and always replace central pixel value by median so that we can reduce the noise. Suppose central pixel value is 100. After finding median, let us assume 50. So this 100 is replaced by 50. So we reduce the salt noise. So this is a simple process of applying median filter to the given image of a kernel size 3x3 or 5x5. So that's why the mathematical formula is very simple. Gxy, this is the output image. So that means input image is nothing but f of xy and output image is nothing but g of xy. That means noise reduced. Here we applied median filter. So therefore g equal to median of f of xy. That is the mathematical formula for median filter. You can see here g of xy equal to median of f of xy. So f of xy is a input image. For that we applied median. After that we'll get output image, that is called g of xy. So here I will give a numeric example, you can understand better. So that this is the input image. You can see this is the 3x3 input image, and we have to calculate the median first. So first what we have to do, arrange the elements in either increasing or decreasing order. So all the 9 elements. After arrange the elements in increasing order, the middle value is nothing but 27. That is the median. So median equal to 27. Now after finding median, the central pixel, what is the central pixel here? This 3x3 submatrix 90. So this 90 is replaced by 27. That means the median value is nothing but 27 and the central pixel is replaced by 27. Now we can see here 27 is very close to the neighboring values. That means surrounded pixels. But here 90 is very high when compared to the surrounding values. So that's why here noise is reduced. When compared to the original image, in the resultant matrix, we reduced the noise. So this is a simple example how to apply median filter. So first we have to find the median. How to find the median? Arrange the elements either increasing or decreasing order. After that, the central element is nothing but median value. But if you have even number of observations, average of middle values are nothing but median value. But here we are taking odd size. That's why there is no issue. The middle observation is nothing but median, and the central pixel value we have to replace with the median value. So what is the central pixel here? 90. That is replaced with 27. Now 27 is very close to the surrounded pixel values, which indicates that so the noise that is called salt noise is reduced. So this is a simple numeric example. Hope you understood how we applied median filter to the given 3x3 simple example. Same thing we can go for generic. So if we have image 500 cross 500, we can take 3x3 like that. We have to move from left to right. So we have to traverse for entire image, and obviously whenever if we are moving from left to right or top to bottom, the central pixel value we have to replace with median value. So here you can see one more example. So here I am taking 3x3. First we have to apply this 3x3 and find the median value. The median value is 1. So that's why the central pixel value is replaced by 1. Next, after that I have to move from left to right. Next 3 by 3 we have to consider. Then again central pixel value is replaced by median. Median is 1. That's why the central pixel value is replaced by 1. Again we have to move from left to right. Again we have to move from left to right. Then no possibility to move from left to right, so we can stop here. The central pixel value is replaced by median, that is 1. Now left to right is over, so we have traversed from left to right. Now we have to go traverse from top to bottom. Now this 3 by 3 we have to consider. Next this 3 by 3, next this 3 by 3, next again top to bottom. Like that we have to traverse for entire image. After that the central pixel values are replaced by median values. You can see the median values. Now at least we can reduce the noise, that is called salt and pepper noise, after applying median filter. I will show hands-on with output images so that you can see what type of noise we reduced after applying median filter. This is the one simple example. So this is the input image, and I applied median filter first 3 by 3. Next I have moved from left to right. Next I have moved from left to right, like that. So first row we have started from left to right, and we reach then next to top to bottom. Next we have started here, and again we reach right, and again we have to start from top to bottom. Again we have reached finally. So when you reach the last 3 by 3 matrix, we have stopped the process, and finally the all the in the final image we are able to see the central pixel value is replaced by median value. Yeah, someone raised it. Yeah, tell me, professor, if you have any query, or you can type your query in the chat box. So in this, any doubt, or maybe whatever we covered so far, any doubt, just you can put in the chat box. No queries. Yeah. I hope you understood what is exactly happening. I'm giving generic, not specific. Whatever example I have considered previous slide, just that is specific to 3 by 3 matrix, but this is a I think a 7 cross 7 matrix. So how to apply 3 cross 3 mask for 7 cross 7 image. So finally we have reached the rightmost corner and no more further extension. Hence we have to stop the process, and finally we'll get output image with noise reduction image. Hope this diagram, I think this image, I hope you understood clearly why how to apply mean. Same thing, if you understand median filter, same thing we can apply for mean filter, max filter, min filter. The concept is same only. Yeah, I did not understand this moving left to right part. Yeah, I will explain what does it mean. Yeah, so I'll, if you want clearly, so I will make empty the screen. Just a second, I'll explain. Duplicate side, and I'll remove this one. Yeah, I will clarify your doubt clearly. Just a second. Nirmala madam, I received your mail, madam. I replied to your mail, madam. No issue. Yeah. So computer vision, actually, I will give briefly. Image processing is basically we are looking for processing of images like noise reduction, or maybe contrast enhancement, or maybe blurring, etc. This type of things we are doing image processing. When you come to the computer vision, it's the incorporated neural networks, etc. There we are looking for basically classification, object detection, object tracking, this type of things. Little bit high level image processing manner that we are going to take in computer vision. So that is the main difference. Image processing means we are looking for low level processing images like a noise reduction, or maybe a contrast enhancement, or it may be some other simple image processing things we are applying. When you go for computer vision, this is little bit high level image processing techniques like image classification by using neural networks, or maybe object tracking, or maybe object detection. This type of high level image processing things we are doing in the computer vision. So even there we have to go for a little bit high-fi algorithms. By using that, we can go for neural networks, artificial intelligence concepts also come to the picture in the computer vision. So I have read your mail today afternoon. I'll reply, man. That is a brief description, I mean, answer for your question. So any other image formats apart from grayscale, RGB? Yes, man, we have, man, not only HSV image formats, we have, and indexed images we have. So when you require, I will explain that also. No need to worry about that, madam. So mainly we are focusing on grayscale, RGB, binary. These things sufficient time being for us. Maybe if you are looking for maybe higher image processing, maybe further image processing, like especially when you are looking for segmentation, etc. There we have to convert other image formats also, like lab color space, LAB lab color space, or HSV color space, or maybe indexed images. Like that, we have various kind of things also available. But here not required time being. Maybe when you require, I'll explain that also. But time being, RGB to grayscale is fine for us because we are in initial stage only. We are not moving higher level immediately. When you are looking for that higher level, I will show what type of other type of image formats also available. Why we have to convert lab color space, in which why we have to take only L channel, that is called luminance channel. By using that, we can process the further image analysis. Like that, so many concepts are available. So, but time being, that is not requirement. I'll explain later. Yeah, the question is, I hope, Nirmala madam, hope you understood what I have explained so far. Yeah, so one question is, I did not understand this moving left to right part. I will, yeah, sorry. I will answer for this. Okay, thank you, madam. Yeah, thank you. Thank you. Anyhow, I will reply to your mail also, madam. I have read afternoon only. So I will reply whatever I have explained, just the same thing. I'll reply to that mail clearly so that you can understand. And one answer for the question that is called why we have to move left to right, I will give clearly. So this is the image. Sorry, I'm not able to write properly. So just I'm writing here. So this is the image. Maybe the size is not the, maybe little bit big image. So 3x3 like this, I'm assuming. So this is the input image. So first we have to apply median, because we can't apply median filter directly to the input image. So entire image, if we take median, maybe one pixel value only, we are trying to replace the central pixel value by median. The basic idea of median filter is we have to find the median value and replace central pixel value by median value so that we can reduce the noise. Now here, why we have, I already told you, we can take kernel size or window size, either 3x3 or 5x5, etc. That is called sub image. And by using that, we can apply median. Now I am taking this 3x3. Try to understand. This is the 3x3 image I considered initially. Now, after finding median value, let us assume after finding median value, I got median is, let us assume 30. So actual central pixel value is 100. After calculating, I got median is 30. So replace central pixel value by 30. So this is clear. So first I have considered this 3x3 sub image because my size of the kernel is 3x3. After finding the median for this 3x3, we know how to calculate median. The central pixel value is 100, that is replaced by 30. Now we can't stop now because we have to look for entire image for applying median filter. Next I have to look for next 3x3. So first column you can remove. Next we can move from left to right. Next 3x3 you can consider. Hope you understood. Now again we have to calculate median. The median is, let us assume 55, but the central pixel value is 250. So the central pixel value is replaced by 55. So this 55 I have to replace. So over. Now again, this is over. Next, I have to from left to right. Next 3 by 3 we have to consider. Next 3 by 3 consider. Let us assume for this 3 by 3, the median value is 40. The central pixel value is 216. Now this value we have to replace by 40. So central pixel value. Now no more extension from left to right. Why? Means we can't frame 3 by 3 matrix, sub matrix. That's why we have to stop the process. Now what it indicates, now we can see in the second row, second element, third element, fourth element, instead of 100, 250, 216, I replace with median values 30, 55, 40. That means we reduced the salt noise. Now left to right is over. Now next, still we have so many other elements. That's why what I'm trying to do, from top to bottom, first row you can leave it, second row you can consider. This 3 by 3 we have to consider, so that we are adding new row, that is the fourth row. We have to apply same. Here we will get median, let us assume 50. Again we have to move from left to right, so that this median value is, let us assume 60. Next again left to right, so that the central pixel value is replaced by median. Same thing again top to bottom. So here the central pixel value 60, 70, 10, 15, 17, or maybe 60, like that we have. Now whatever central pixel values we have, higher values, all we reduce it to minimum value which are surrounded by the other values, so that we reduce the salt. Maybe pepper noise also we can reduce like this. Hope you understood why I'm moving. If we are not moving, what happens? Only one pixel we are reducing. What about other pixels per entire image? That's why I'm considering 3 by 3, that I'm moving from left to right. Once if I complete right, then again moving from top to bottom, again left to right, top to bottom. Once if we reach the rightmost corner, we have to stop the process. Suppose if we consider 5 cross 5, then what we have to do? We have to consider initially 5 cross 5 subimage, and for that we have to calculate median, then we have to replace. But 5 cross 5, if we consider, some of the salt and pepper noise we can avoid. We are not able to avoid. That's why in general we can go for 3 cross 3, so that we are able to cover entire image. So hope you understood. Yeah, clear. Yeah, thank you, Jose. Yeah, thank you, ma'am. I don't know, madam or sir. Thank you for. So this is the way we have to process. Either if you understand this one, median filter, max filter, minimum filter, average filter, whatever filter, if you apply, same concept only. Maybe there sometimes filters may be different, that we'll discuss when you are looking for that type of filters, that we can understand clearly. Yeah, so this is the median filter, how we have to apply to the given input, but still we don't know how we are going to apply Matlab command. Here it's very simple Matlab function. By using that, we can apply median filter to the given input image. What is the Matlab function we are going to use? We are going to use one simple Matlab function that is called midfilt, MEDFILT2. By using this function, we can apply median filter to the given input image. When you are looking for Scilab, there immedian is a function. By using that, we can apply median filter to the image. But in Matlab, we can apply midfilt2. So by using that, we can apply median filter. So this hands-on in here I will execute later. I will show input output. So this is the image with noise. So here only we have to remember one thing. So whenever if you are applying median filter to the given input image, what is the Matlab function? Midfilt2. Input image we have to give in the bracket, so that we'll get output image in image without any noise or reduced noise. So image with noise, here we can see salt and pepper noise, and after applying median filter, denoise image, we reduce the noise here. We are not able to find much. Maybe still little bit noise is there. We can't avoid 100%, but we reduce the noise here when compared to the original image. We reduce the noise here. Here also, so this is the original image after applying median filter. Anyhow, this I'll do hands-on also later. So midfilt2, input image J. After that, the noise is reduced. This is for grayscale images. Even I'll explain for color images also how to apply a median filter for color images also I'll explain. So based on that, we can apply median filter for grayscale image as well as color images. And same concept we can apply for max filter, min filter, average filter, or maybe low pass filters. So that's why initially, if you understand one filter, then rest of the filters you can understand easily, because the concept is same. Only thing is formulas are different. So here also you can see this is the original image, and this is the image with noise minimized. So that salt and pepper noise minimized in the output image, and we can see better. And here also And here you can see one interesting point. Tomorrow session I will show hands-on also. This is the original image. In the original image we are able to find salt and pepper noise, and I applied here 3x3 filter. I already explained what is the meaning of 3x filter. So 3x3 filter I applied for this means 3x3 sub images I have to replace central pixel value by median. Like that we have to apply for entire. When you apply 3x3 filter for this median filter, then we reduce a little bit noise salt. When you apply 5x5, this is 5x5 median filter I applied. So of course noise reduced, but something blurring is happening here. So that means the quality not up to the mark. And when you apply, see, now we can see here. So this is the image with 3x3 filter, and this is the image with 5x5 filter. What we found the difference, while applied 3x3 filter, we are able to reduce the noise, but while applied 5x5, we reduce the noise, but something blurring is there. The quality of the image is not up to the mark. Suppose if I try to apply 7x7 filter, so if I apply 7x7 filter, we can see still we are not able to see, lot of blurring is there. Of course, noise may be reduced, but lot of blurring is there. The quality is not up to the mark. And when you apply 9x9 filter, so we are not able to see properly the objects. Maybe noise reduced or not, there is another issue, but we are not able to observe the proper quality of the image. So what is the conclusion here? While applying the size of the filter, try to apply various sizes: 3x3, 5x5, 7x7, 9x9, 11x11, 13x13. Like that, we can apply various sizes. Especially when you are doing research, we have to look for all the sizes of the filters, out of which try to look for which filter is giving better quality image with noise reduced. That is the final one. So finally, we can fix this is the better quality image with noise reduced. And the conclusion is we have to apply median filter for the given input image of kernel size is 3x3. That means size of the filter is 3x3. So in research, while doing research paper also, so we have to display all the output images, and maybe you can evaluate mathematically by using PSNR or SNR or maybe entropy, etc. By using that mathematical measures or maybe visual appearance, we can fix or we can make a conclusion. So the median filter is better for noise reduction of the given input image of kernel size or mask is 3x3. But when you are applying 5x5, 7x7, etc., the quality of the image is not up to the mark. That's why in our research we have fixed a median filter with size 3x3. Like that, we can make a conclusion. If you are not making a conclusion like that, immediately we will get a question from the viewer. So what is the size of your mask or kernel? Even I faced that questions when I applied one of the paper to the Elsevier journal. I will show that papers also as a research directions. My papers only I will show. So such type of situation also possibility is there. That's why try to apply all size of kernels. Based on that, we can finalize which is the best for the given input image to reduce the noise. So these things I will do hands-on also, because today almost 6:25. And how to apply color images also I will explain how this is the how to apply color images. Suppose if we take this is a color image with noise, how to reduce this here we require some other concept. I will explain in tomorrow's session. So many things are there. These things I'll explain tomorrow. I will continue tomorrow's session. So leave it this one. Yeah. So for resources, additional resources to learn digital image processing and Matlab, we can same textbook what I have shown yesterday. So digital image processing by Gonzalez, that is a standard textbook. If you are not able to understand, let us assume if you are beginner, we can go through any local textbook also, because sometimes it's difficult to understand for especially beginners. And for Matlab, same author, digital image processing using Matlab. So that was the second day section. We discussed today what is the meaning of image enhancement and what are the things we are going to do in image enhancement and noise reduction by using median filter. Concepts we discussed and input output images I have shown, but hands-on is left. Tomorrow's session I will do hands-on, and also how to apply median filter for color images, and what about other filters, that also we'll discuss tomorrow, and what are the other image enhancement techniques also we'll try to complete tomorrow, maybe in the rest of the sessions. So that is the end of the session. If you have any queries, you can send mail. So even I received mails, I will reply to that mails. No need to worry, because of some hectic schedules, not able to reply. But surely I'll reply to the mails what I have received, and thanks for the mails also. So if you have any queries, you can type in the chat box, or you can send queries to the mail ID jshomsekar@gmail.com. Even I will show research directions also. Once if we complete these concepts, I will show my research articles only published in Elsevier, SCI Index journals, etc., so that we can get still more clarity how to apply for research point of view also. Yeah. So thank you. So that is the end of the session. If you have any queries, you can send a message or you can ask me. Otherwise, later also we'll discuss, not an issue.
Thank you, sir, for the wonderful session, and thank you so much for the participant. We appreciate you taking time out of your day to give your informative session. So I believe the second session of the FDP was informative for all, and the next section will be start sharply at 3 p.m. tomorrow. On behalf of IFERP, I heartily thank all the professors, academicians, and delegates who have joined us today. I would like to extend my gratitude to our esteemed speaker, Dr. J. Somashekar, for delivering the keynote speaker.
Yeah,
Thank you all.
yeah. Thank you, madam. Thank you.